Sup everybody, graphing some functions here and stating domain and range. The top row should be pretty straightforward for us. The bottom row have a little bit more going on, but still nothing crazy that should scare us. So let's do A first. Y equals negative x squared. So if we're graphing y equals negative x squared, you should recognize that the mother function is x squared, which is a parabola that looks like that. So we are graphing negative x squared, which means it's going to look exactly like the parabola of y equals x squared, except it is flipped upside down. Anytime you have a negative out front of the function, in front of everything, it flips it upside down. So you can think of like some parentheses that are there, even though we don't see them. That's what's really happening. So if we were to plug a number in, we would square it, and then we would just make it the opposite of what it was. Make it negative in this case. So I know I'm going to have the point 0, 0. If you square 0 and then make it negative, you get 0. So what about 1 and negative 1? We should know the shape of a parabola. We're going to have points right there at negative 1, negative 1, and positive 1, negative 1. Well, what if we go 2 over from that vertex point? How far down do I need to go from the vertex? Well, I need to go down 4 because 2 squared is 4. So I'm going to have these points there, and that should be enough to get a decent sketch of this inverted parabola. There you go. Domain and range. Domain is going to be all real numbers. So I'm just going to say x in the set of all real numbers like that. That's set Boder notation. I could do it in interval notation as well. I would just say x is in the interval going from negative infinity to positive infinity. When you're thinking about domain, you should just ask yourself, is there anything I'm not allowed to plug in? And no, not in this instance. You can plug in any real number, square it, and make it negative, so we're good. What about range? Well, notice our graph is starting at 0, 0, and then it's going down forever. That 0, 0 is the highest point this function ever hits. So my range is going to be all y values that are less than or equal to 0. So if I'm doing set Boder notation, my y values are in the set of real numbers with the condition, so such that y is less than or equal to 0. If you're doing interval notation, y is in the interval going from negative infinity all the way up to 0 and including it. And there you have it, y equals negative x squared.